Greetings everyone. Today we're going to explore Euler's number and natural logs. We do have a foldable for this which will be helpful, and make sure you have your calculator ready. Make sure at any time during this video that you pause when needed, write down, and just listen. First, let's talk about Euler's number. Euler's number, we want to kind of think of it like pi. Pi is the easiest comparison in that pi is an irrational number, and sometimes we abbreviate it to calculate with it. And so in this case, it's similar. E is just a representation, a letter that represents an irrational number. Okay? In your calculator, here's what I need you to practice. Find that E key. It's usually around the LN key. Graphing calculators typically bottom left. Find that E, and it provides an exponent. Well, what exponent will tell me the actual value of E? 1. So when you type that in, you should get approximately 2.718281828. Some random facts. The number E is named for its inventor, Euler, who lived in the 1700s. It's an irrational number, kind of like pi. So pi, you take the circumference, you divide by the diameter, right? So a couple ways you can approach the value of E, approach it, we never can get exactly it, is by this formula here. Don't need to have that memorized, just wanted to give you some history. Today we're going to start off by graphing, and here's in our class one of the few times I don't need a transformation table. We are just going to create a table straight up using our calculator. So let's come up with some values. If I plug in -2, what I'm typing in my calculator is 2e. -2 plus 3 would be to the first. So we want to type that in. Practice this with your calculator. Don't just jot these down. I want to make sure that you are typing in correctly. I'm actually going to fill in all of these first since I have the space. I just want to make sure I'm typing in correctly. So -1 plus 3 would be 2, 0 plus 3, right? I just want to make sure. 2 times e to the second. Ooh, notice how our numbers are jumping up pretty quickly already. 2 times e to the third. Oh my goodness, I'm typing it in with you as I make this video. 2 times e to the fourth. Since it's a table, it doesn't matter to me how many values you write down or rounding, because it's going to be very much approximating on this graph. So I've got 296. Oh my goodness. Okay, so first thing, if I'm going to graph these, okay, I'm going to change my scale. I'm going to say this is 100, this is -100. I'm going to count by tens and show me in some way that that's what the scale is changed to. Otherwise, I can only graph one dot, and that's not going to be very good. So at -2, I'm at 5 point something. At -1, I'm at 14. At 0, I'm at 40. At 1, I'm at 109. And I can't graph that last one, but 4 dots is better than 1. Now, exponential. This is still an exponential graph, meaning I'm going to see something that looks like all the exponential work we already did. So in this case, exponential growth or decay, well, my base is e, and e is 2 point something. E is greater than 1, so it's automatically growth because e is greater than 1. My asymptote is going to be y equals 0 because we didn't add or subtract anything as a vertical shift. My domain, as similar to other exponentials, is forever. My range, however, approaches 0 and infinity. Let's try one more. This one tends to throw students off, so let's talk about it. First of all, I'm going to go backwards. Growth or decay? My base is still e. E is greater than 1. This is going to be growth. Put a star by that, because this is where it's going to look weird. My asymptote, well, if I have a +1, guess what? It's going to be 1. my domain, I'm going to make an assumption. It's going to be negative infinity to infinity. And for the range, let's actually wait a second. So let's calculate. If I plug in -2 for x, that would be a double negative. So it would actually be e to the second plus 1. If I plug in e to the -1, that'd be a double negative, so it'd be to the first. E to the 0 plus 1, well wait, anything to the 0 power is 1. E to the first would make it a -1. And to the second would be -2 plus 1. So I like to just prep and make sure I'm typing it in correctly. First, I'm going to type it in as we work on this. So I'm getting like an 8.3 e to the first plus 1. Make sure you're getting out of the exponent as you type this in. I've got a 3.7. I already took care of 0. E to the -1 plus 1. 1.36. Again, practice with your calculator. Make sure you're getting the same thing as me. -2 plus 1, 1.1. So very attainable on this graph. -2, 8 and a little bit. -1, 3.7. 0 is exactly 2. 1 is 1.36. 2, 1.1. So now I can see how I'm approaching that value of 1. So show that by cruising along the asymptote. My range, I can now see it clearly, is from 1 to infinity, but parentheses, right? Now, look at that graph. That graph looks like decay, but it's not. It's growth because the base is e. So what changed it? This negative creates a reflection in the y-axis. We haven't had that very much this year, so it looks different. We base growth or decay on the base. The negative exponent is what's throwing us off. All right, let's switch gears. So that was our little introduction as far as graphing goes. Let's remember that common log is base 10. Right? If you just see log, you know it's a base 10. We already understand that from our previous lessons. But let's take a moment to talk about natural logs. So if I have a log that has a base of e, that would look like this, log base of e. E is a number, so that works. A log that has a base of e can be simplified to just say natural log. Now, natural log is written as ln. Backwards, I know. And if you're writing it, I encourage you to do a cursive L than an N. It just makes it a little easier to make sure it's not a 1 or some other symbol. Now, we do have the ln key on your calculator, but could you use the log key with a base of e? Sure, your calculator would require an exponent, so you could put just a little e to the first in there. But that's more typing. It really is when you can just use that natural log key. You don't have to write this down, but let's talk about how that looks if I really expand it, okay? Let's say I have e to the x equals n, and I say, hey, I want you to convert that exponential to a log. We've been doing that, right? Let's remember this. The base becomes the base. The exponent becomes the answer. What's remaining becomes your value. We've done that. That would be nothing new. You could have done that before today and not even realized it. But what we're improving on is we're saying, oh, log base e can be simplified to just natural log. It's less to type in. So first, let's practice converting. In your notes, first and foremost, if you would write this conversion, and let's talk about that conversion, okay? The exponent still becomes the answer. That's the main thing you have to remember. The answer becomes the value. Okay, so we can still kind of use those little tricks from numerical bases, or excuse me, integer bases to logs. We can still use that vocabulary to help us. All right, let's convert. If I have the natural log of smiley face equals $, well, exponential form means base e. The answer becomes the exponent. What's remaining becomes your answer. Let's try again. ln of 1 equals 0. Well, base e is the opposite of natural log. The answer becomes the exponent, therefore what's remaining is my value. And that makes sense, right? E to the 0 is 1. Now let's go the other direction. If I give you a base e, you know you got to write ln. And again, I actually prefer a cursive L. The exponent becomes the answer. What's remaining becomes your value. And this you could check in your calculator. Let's work on rewriting examples and then solving for x. So first of all, I have this equation and I can't solve it the way it is. So I have to convert it into natural log. The exponent becomes the answer. What's remaining becomes my value. Well, I can plug that in. Go to the ln key on your calculator, type in ln 148.413. Keep that in your calculator, right? It's about 4.99 and a bunch of other stuff, right? You don't even need to write this down because in your calculator, you're just going to subtract that 1 from your previous answer. And here's how I recommend writing it. Look at those decimals. Let's just say it's about 4. Because here's what happened. I gave you a rounded answer. So that's why you're not getting exactly 4. But if you were to type in e to the 5th, you would get the exact decimal. Let's take a look at this one. Here I'm given a natural log and I don't know what the answer is. So I'm going to convert to base e. The answer becomes the exponent. What's remaining becomes my value. So let's practice. Let's type in, using our calculator, e to the 2.639. Look at that value. I'm getting actually approximately 14. Now reminder. You cannot take the log of a negative or a 0, so you can't take the natural log of a negative or a 0. That still holds true. The last thing I'd like you to try and mess with is just calculator functions. These are going to be decimal values, but what I really need you to acknowledge is down here, if you type 2ln, your calculator is likely going to create a parenthesis. And so before I continue, I have to close the parenthesis. Do you see what happened there? If you don't close it, it's going to carry on and take the ln of all of that. And we don't want the ln all of that. So what I'm going to ask is if you would please just pause the video here, plug these in your calculator, and make sure you're getting the same decimal as me. Alrighty, so again, calculator is necessary to complete these operations. Let me know what questions you have. Check out Google Classroom to see what the task is at hand. And until next time, have a good one.